we're going to talk about chemical changes. So chemical change is a change that you might not be able to, you might be able to see it, but you won't be able to, understand that actually chemical change is happening. So how is that possible? So chemical change is a change that happens in the molecular level. Okay, so the molecule or the substance changes itself to another substance, and that is called a chemical change. So here the substance doesn't remain same. Okay, so the entire substance change. Say for example, a compound was previously something and then it becomes something else. So that kind of change is a chemical change. Here you can see that something is burning, right? Woods are burning. If you chop woods, that's a physical change. But if you burn woods, then what becomes that wood is basically a hydrocarbon. Okay, so if you it's not perfectly hydrocarbon, but it has hydrocarbon compounds. So if you burn woods, then what happens is these here carbon dioxide is created and as well as water is created. So here what happens is that the compounds doesn't remain the same. You have seen that if you burn something, then after burning the whole thing down, the only thing left is the ashes. So yeah, so burning something is burning something is a chemical change because the compound doesn't remain same. It entirely changes. It converts from one type of substance to another type of substance. Yeah, here you can see the burning something. Here's a match that's burning. So yeah, burning something is a chemical change, and chemical change is something that changes the entire substance, that changes the entire compound. It happens in the molecular level. So let's find out some more about it. Here you can see methane. Okay, if you if you add methane and oxygen, then what you will get is you will get carbon dioxide and water. Here you can see that you have taken methane and oxygen, right? But what you're getting carbon dioxide and water. If you see the molecules here, here's a one carbon, one carbon atom. Here's also one carbon atom. Here are one, two, three, four oxygen atoms, and here two and two oxygen atoms. Here are four hydrogen atoms. Four hydrogen atoms are present here. Also here, four hydrogen atoms are present, right? So you can see that the entire amount of atoms remain same, but the difference what happens here is their structure changes. Okay, before they used to be like this, and after the reaction they become something else. So the change happens in its structure, in its molecular structure. The molecules, the atoms shuffle within themselves. Obviously they shuffle with a perfect order. That's why you will always get carbon dioxide and water if you do a reaction of methane and oxygen. Okay, by the way, methane is a hydrocarbon and methane is basically an alkane. Okay, so yeah, this is this type of change, this is considered chemical change. Why this is chemical change? Because here the products you're getting, by the way, this is a chemical reaction and these are called reactants and these are called products. So the reactants were alkane and oxygen, right? But the products you get is a carbon dioxide and water. So the reactants and products are entirely different from each other, but the total amount of atoms are same for both of these. Here there's a one carbon atom, four hydrogen atoms, four oxygen atoms, four oxygen atoms as well. So the only difference here is they have shuffled within themselves. They have bonded. Previously they used to bond like this, and afterwards they bonded like this. So the change happened in its bonds. The change happened at chemical level, and this is that's the reason why this is called a chemical change. Now let's see. Here you can see that there was methane molecule and oxygen molecule, and then after reaction they have just shuffled. Okay, they have just shuffled from and created carbon dioxide molecules and water molecules. Okay, so if we see the video again, okay, see here the the total amount of atoms remain same. The only difference here is they are arranging in a new order. This arrangement of new order is causing this chemical change, and the substance is changing entirely. The properties of methane, the properties of oxygen are entirely different from the properties of carbon dioxide and properties of water as well. So that's why this kind of change is considered a chemical change. Here you have seen the total amount of atoms remained same, right? But the only difference happened here that the atoms used to be arranged like in a order, and afterwards they have arranged in another order, and that's what caused this chemical change. So this is a this is a chemical change. So chemical change happen at the molecular level. The compound entirely changes itself to a different compound, okay, and the the characteristics won't match. The previously maybe it used to be something and afterwards it will become something else, and these characteristics will never match, okay. So that kind of reaction is it, or it's a chemical reaction, and this kind of change is considered a chemical change. So let's see some more examples of chemical change. Here we have some examples of chemical change. We have seen iron rust, right? Iron rust means you have seen, iron metals, iron metal made substances or objects in your house, and if you leave those if you leave those substances in the open air, then you have seen that there is a layer of brownish or reddish brownish substance, and that is called rust, and that is called iron rust, okay. So this iron rust, having iron rust, why iron rust, why this thing happens, or why this thing happens to irons is because a chemical reaction. The iron react with the oxygen of the environment, and that's how iron rust is created. So iron rust, or creation of iron rust, or this process, this is a chemical change. Then we have burning something. If you burn something, then the thing becomes ash, right? So the entire compound changes, entirely changes. Before it used to be wood, and then it becomes ashes, right? So that's a chemical change. Then we have cooking an egg. If you cook an egg, then that's also a chemical change. If you bake a cake, that's if you bake cakes, that's also a chemical change. If you do electroplating, we're gonna learn about electroplating more, because electroplating is a really interesting topic. Electroplating means that you're putting a layer on a metal with another metal, which is a very fun and interesting thing. And electroplating process is also a chemical change. Then we have banana rotting in the banana. If you keep the banana for several days, or for like 1 or 2 weeks in your house, then the banana starts to rot, right? And this process, this rotting process, is also a chemical change. Then we have vinegar and baking soda. Have you ever tried some fun some fun chemical experiments in your house? I think you should. I bet you have vinegar and baking soda or baking powder in your house. So what you can do is you can take the vinegar and the baking powder together, and if you mix those, then you will see bubbles are created and heat is created, and that type of change, and that is a chemical reaction, and that type of change is a chemical change, okay. And when you mix vinegar and baking soda together, that's a chemical reaction. That's why bubbles are created, and the pot or the container you're gonna use to do the reaction will become warm, because this chemical reaction produces heat, and this type of reaction is also called neutralization reaction, which we will be discussing soon. And last one, we have fireworks. We have seen fireworks, right? So fireworks are really pretty, really beautiful, really fascinating. So fireworks is also a chemical change. Okay, so these were the examples of chemical change. There are several other chemical changes all around your yourself, you do these or you see these on your daily basis, you just don't understand, or maybe you just don't give it that much attention to understand, oh, this is a chemical change. Okay, so yeah, this is everything about chemical changes.